Coordinate geometry. The horizontal line is called the x-axis and the vertical line is called the y-axis, and their point of intersection is called the origin. The x and y-axis divide the plane in 4 quadrants, 1, 2, 3, 4. Now numbering the 2 dimensions with positive and negative values, we get this graph. Such graph of 2 number lines helps us locate any point on the plane using x and y coordinate given as x coordinate, y coordinate. For example, consider this point A on the graph. X coordinate of point A is -2 and y coordinate is 3. X coordinate is also called as abscissa and y coordinate is also called as ordinate. Similarly, we can also locate any point with the given coordinates. This whole coordinate system we just learned is called Cartesian coordinate system, named after René Descartes, a French philosopher, mathematician and scientist born on 31st March 1596. These concepts of coordinate system in geometry is called coordinate geometry. Now we will learn to find distance between any 2 points. 1. Lying on the axis. 2. Lying anywhere in the xy plane. It has 2 possibilities. A. Parallel to either x or y axis. B. Not parallel to any of the axes. Consider first case, lying on the axis. Remember, the y coordinate of points lying on x-axis is 0 and the x coordinate of points lying on y-axis is 0. Let us take 2 points on x-axis, A, whose coordinates are x1, 0 and B, whose coordinates are x2, 0. As we can observe, x2 is greater than x1, therefore distance AB is equal to x2 minus x1. Similarly, we can also find the distance between 2 points lying on the y-axis. Coordinates of P are 0, y1 and Q are 0, y2. Since y2 is greater than y1, distance PQ is y2 minus y1. Consider 1 parallel to any axis in the xy plane. In the figure, segment AB is parallel to x-axis. Y coordinates of points A and B are equal. Drawing segment AL and segment BM perpendicular to x-axis, we get quadrilateral ABML is a rectangle. Therefore, AB is equal to LM, but LM is equal to x2 minus x1. Therefore, AB is equal to x2 minus x1. Therefore, distance between the points making a segment parallel to x-axis will be equal to x2 minus x1. Similarly, we can derive that distance between the points making a segment parallel to y-axis is y2 minus y1. Case 2. Not parallel to any axis in the xy plane. Taking any 2 points A with coordinates x1, y1 and B with coordinates x2, y2 in the xy plane, join the points to get segment AB. We first form right angle triangle keeping segment AB as the hypotenuse. From point B, we draw a perpendicular BP on x-axis. Now, draw another perpendicular AD on segment BP. The coordinates of point D are x2, y1. Since AD is parallel to x-axis, distance of AD is equal to x2 minus x1. Also, BD is parallel to y-axis, distance of BD is equal to y2 minus y1. In a right angle triangle ADB, by Pythagoras theorem, AB square is equal to AD square plus BD square. Therefore, AB square is equal to x2 minus x1, the whole square, plus y2 minus y1, the whole square. This is the distance formula. AB is equal to square root of x2 minus x1, the whole square, plus y2 minus y1, the whole square. Now we will apply the formula in an example. Take any 2 points A whose coordinates are 6 and 7 and B whose coordinates are 10 and 4. Now let coordinates of point A be x1, y1 and that of B be x2, y2. Using distance formula, we find distance of segment AB. Distance between points A and B is equal to root of 10 minus 6, the whole square plus 4 minus 7, the whole square. That is root of 4 square plus minus 3 square, which comes out to be root of 16 plus 9, and 16 plus 9 is 25, and square root of 25 is equal to 5. Therefore, distance between points A and B is 5 units. Second example, find A if distance between the points P, A, 4 and Q, 2, 8 is root 17. Solution. Here, coordinates of P are A, 4 and Q are 2, 8. Therefore, x1 is equal to A, y1 is equal to 4, x2 is equal to 2, y2 is equal to 8. By distance formula, distance between points PQ is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Therefore, root 17 is equal to root of 2 minus A the whole square plus 8 minus 4 the whole square. That is, root 17 is equal to root of 4 minus 4A plus A square plus 4 square, which is equal to root of 4 minus 4A plus A square plus 16. That is, root 17 is equal to root of 20 minus 4A plus A square. Now, taking square on both sides, we get 17 is equal to 20 minus 4A plus A square. Subtracting 20 on both sides, we get minus 3 is equal to minus 4A plus A square. That is, A square minus 4A plus 3 is equal to 0. Now, we split minus 4A as minus A minus 3A. Taking A common from A square minus A and minus 3 common from minus 3A plus 3, we get A into A minus 1 into minus 3 into A minus 1 is equal to 0. Therefore, A minus 1 into A minus 3 is equal to 0. That is, A minus 1 is equal to 0 or A minus 3 is equal to 0. So, we get A is equal to 1 or A is equal to 3. Collinear points. What are collinear points? 3 or more than 3 points are said to be collinear if they lie on a same line. Any 2 points on a plane are always collinear. Points that do not lie on the same line are non-collinear points. So, with non-collinear points, various shapes like triangle, quadrilateral, pentagon, etc. can be formed depending upon the number of points. How do we show that the points are collinear or not? If the sum of any 2 distances out of 3 is equal to the third distance, then the 3 points are collinear. For that, let us take 3 points P, Q and R. Given that distances PQ is equal to 5 units, QR is equal to 7 units and PR is equal to 12 units. Now, distance PQ plus distance QR is equal to 5 plus 7, which is equal to 12, that is distance of PR. Therefore, distance PQ plus distance QR is equal to distance PR. Then the points P, Q and R are collinear. Now, we will take another example to check whether the point P with coordinates 1, minus 3, Q, 2, minus 5 and R, minus 4, 7 are collinear or not. For distance PQ, let coordinates of P be x1, y1 and Q be x2 and y2. x1 is equal to 1, y1 is equal to minus 3, x2 is equal to 2, y2 is equal to minus 5. Distance between points PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to root of 2 minus 1 the whole square plus minus 5 minus into minus 3 the whole square. That is equal to square root of 1 square plus minus 5 plus 3 the whole square, which is root of 1 square plus into minus 2 square is equal to root of 1 plus 4, we get root 5. Now for distance QR, let coordinates of Q be x1, y1 and R be x2, y2. x1 is equal to 2, y1 is equal to minus 5, x2 is equal to minus 4, y2 is equal to 7. Distance between points QR is equal to square root of x2 minus x1, the whole square, plus y2 minus y1, the whole square is equal to root of minus 4 minus 2, the whole square plus 7 minus minus 5, the whole square. That is equal to square root of minus 6 square plus 12 square, which is root of 36 plus 144 is equal to root of 180. We get 6 root 5. Now for distance PR, let coordinates of P be x1, y1 and R be x2, y2. x1 is equal to 1, y1 is equal to minus 3, x2 is equal to minus 4, y2 is equal to 7. By distance formula, distance between points PR is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to root of minus 4 minus 1 the whole square plus 7 minus minus 3 the whole square. That is equal to square root of minus 5 square plus 10 square, which is root of 25 plus 100 is equal to root of 125. We get 5 root 5. Now we have distance PQ is equal to root 5, QR is equal to 6 root 5 and PR is equal to 5 root 5. Therefore QR is the longest distance. Now PQ plus PR is equal to root 5 plus 5 root 5 is equal to 6 root 5. Therefore distance QR is equal to distances of PQ plus PR. That is, point P lies between points Q and R. Try some more problems for practice. Section formula. Point P divides segment AB in the ratio m is to n. Let coordinates of A be x1, y1, B be x2, y2 and P be xy. Draw segment AC, segment PQ and segment BD perpendicular to x-axis. Coordinates of C are x1 0, Q are x 0 and D are x2 0. Segment AC is parallel to segment PQ is parallel to segment BD. Therefore, by property of intercepts of three parallel lines, AP upon PB is equal to CQ upon QD is equal to M upon N. CQ is equal to x minus x1 and QD is equal to x2 minus x. Substituting the values we get x minus x1 upon x2 minus x is equal to M upon N. Cross multiplying we get N into x minus x1 is equal to M into x2 minus x. Therefore, nx minus nx1 is equal to mx2 minus mx. Therefore, nx plus mx is equal to mx2 plus nx1. Taking x common in LHS. Therefore, x is equal to mx2 plus nx1 upon m plus n. Similarly, by drawing perpendiculars by A, P, B to y-axis, we get y is equal to my2 plus ny1 upon m plus n. Therefore, coordinates of point P that divides the segment in the ratio m is to n are mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. Example: point P divides segment joining points A 2, 4 and B 5, 8 in the ratio 2 is to 3. Find coordinates of point B. Let coordinates of A be x1, y1, B be x2, y2 and let P be xy. Now x1 is equal to 2, y1 is equal to 4, x2 is equal to 5, y2 is equal to 8. Point P divides segment AB in the ratio m is to n. Therefore, m is equal to 2 and n is equal to 3. By section formula, x is equal to mx2 plus nx1 upon m plus n. Therefore, x is equal to 2 into 5 plus 3 into 2 upon 2 plus 3. Therefore, x is equal to 10 plus 6 upon 5. That is, x is equal to 16 upon 5. Similarly, y is equal to my2 plus ny1 upon m plus n. Therefore, y is equal to 2 into 8 plus 3 into 4 upon 2 plus 3. Therefore, y is equal to 16 plus 12 upon 5. That is, y is equal to 28 upon 5. Midpoint formula. Here, P whose coordinates are x and y divides segment AB, where coordinates of AB x1, y1 and BB x2, y2 in equal ratios. According to section formula, coordinates of P are mx2 plus nx1 upon m plus n, my2 plus my1 upon m plus n. Substituting m is equal to n in section formula, we get P is equal to mx2 plus mx1 upon m plus m, my2 plus my1 upon m plus m, which is equal to m into x2 plus x1 upon 2n, m into y2 plus y1 upon 2n. Since m is the common factor, it gets cancelled out. Therefore, we get P is equal to x1 plus x2 upon 2, y1 plus y2 upon 2. This is called as midpoint formula. Let us understand this with an example. Point C is midpoint of segment joining points P, 2, 4 and Q, 8 and 10. Find coordinates of point C. Let coordinates of point P be x1, y1, Q be x2, y2 and C be x, y. According to midpoint formula, x and y coordinates of C are given by x is equal to x1 plus x2 upon 2. Therefore, x is equal to 2 plus 8 upon 2. That is, x is equal to 10 upon 2. Therefore, x is equal to 5. And y is equal to y1 plus y2 upon 2. Therefore, y is equal to 4 plus 10 upon 2. That is, y is equal to 14 upon 2. Therefore, y is equal to 7. Hence, coordinates of point C are 5 and 7. Try some more problems for practice. Centroid formula. To learn centroid formula, we must first understand what a centroid is. Centroid is the point of intersection of all three medians of a triangle. This centroid divides the median in the ratio 2:1. Now we will learn to derive a formula where a median and a centroid of a triangle are given. A x1 y1, B x2 y2, C x3 y3 are the vertices. Segment AD is the median and G x y is the centroid that divides the median AD in the ratio 2:1. D is the midpoint of segment BC. By midpoint formula, coordinates of D are x2 plus x3 upon 2 and y2 plus y3 upon 2. Therefore, according to section formula, coordinates of G will be given as x is equal to 2 into x2 plus x3 by 2 plus 1 into x1 upon 2 plus 1. In the denominator, 2 plus 1 becomes 3. In the numerator, 1 times 1 gives 1 and 2 cancels out. So we get x is equal to x1 plus x2 plus x3 upon 3. Similarly, y is equal to y1 plus y2 plus y3 upon 3. Thus, if x1 y1, x2 y2 and x3 y3 are the vertices of a triangle, then the coordinates of the centroid are x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. This is the centroid formula. Example, find the centroids of a triangle XYZ. if coordinates of its vertices are x minus 2 and 4, y 3 and 5, and z 8 and minus 6. Solution. Let coordinates of x be x1, y1, y be x2, y2, and z be x3, y3. Let G be the centroid of the triangle. According to centroid formula, coordinates of G are given by x is equal to x1 plus x2 plus x3 upon 3, that is equal to minus 2 plus 3 plus 8 upon 3 is equal to 9 by 3, which is equal to 3. Y is equal to y1 plus y2 plus y3 upon 3, that is equal to 4 plus 5 plus minus 6 upon 3 is equal to 3 by 3, which is equal to 1. Therefore, coordinates of G are 3 and 1. Try some more problems for practice. Slope formula. Slope formula helps us to find how steep a line is. If x1, y1 and x2, y2 are any 2 points in line L, the ratio y2 minus y1 upon x2 minus x1 is called the slope of line L. Slope of 1. X-axis and any line parallel to x-axis. 2. Y-axis and line parallel to y-axis. First, we consider slope of x-axis and any line parallel to x-axis. Take 2 points x1 and 0 and x2 and 0 on x-axis. Slope of x-axis is equal to 0 minus 0 upon which is equal to 0. Therefore, slope of x-axis and any line parallel to x-axis is 0. Second, y-axis and line parallel to y-axis. Let us take 2 points 0 y1 and 0 y2 on y-axis. Slope of y-axis is equal to y2 minus y1 upon 0 minus 0, which is not defined. Therefore, slope of y-axis and any line parallel to y-axis cannot be determined. Slope of lines that are not parallel to any of the axes. Consider a line L that intersects x-axis at any point T. Take 2 points P, x1, y1 and Q, x2, y2 on line L. Draw QS perpendicular to x-axis, PR perpendicular to QS. QS is parallel to y-axis, PR is parallel to x-axis, implies PR is parallel to TS. Therefore, QR is equal to y2 minus y1 and PR is equal to x2 minus x1. Therefore, QR upon PR is equal to y2 minus y1 upon x2 minus x1. Take this as equation 1. Line TQ makes an angle theta with the x-axis. Therefore, QR upon PR is equal to tan theta. Since tan theta is equal to opposite over adjacent, this is our second equation. From equations 1 and 2, we get y2 minus y1 upon x2 minus x1 is equal to tan theta. Therefore, M is equal to tan theta. Example 1. Find the slope of a line making 30-degree angle with the positive direction of x-axis. Solution. Theta is equal to 30 degree. Therefore, slope is equal to tan theta, which is equal to tan 30, that is equal to 1 by root 3. Therefore, 1 by root 3 is the slope of the line. 2. Find the slope of the line passing through the points A, minus 2 and 4 and B, 6 and minus 3. Solution. Let x1 be equal to minus 2, y1 be equal to 4, x2 be equal to 6 and y2 be equal to minus 3. Therefore, slope of line AB is equal to y2 minus y1 upon which is equal to minus 3 minus 4 upon 6 minus 2, that is equal to minus 7 upon 6 plus 2, which is equal to minus 7 upon 8. 3. Find K if line LM is parallel to line NO and L 2, 4, M 3, 6, N 3, 1 and O 5, K. Solution. Consider L 2, 4, M 3, 6. Let x1 be equal to 2, y1 be equal to 4 into 2 is equal to 3 and y2 be equal to 6. Therefore, slope of line LM is equal to y2 minus y1 upon, which is equal to 6 minus 4 upon 3 minus 2, that is equal to 2 by 1, which is equal to 2. Therefore, slope of line LM is equal to 2, equation 1. Now consider N, 3, 1 and O, 5, K. Let x3 be equal to 3, y3 be equal to 1, x4 is equal to 5 and y4 be equal to k. Slope of line NO is equal to y4 minus y3 upon, which is equal to k minus 1 upon 5 minus 3, that is equal to k minus 1 upon 2. Take this as second equation. Given that line LM is parallel to line NO, slopes of parallel lines are equal. That is, slope of line LM is equal to slope of line NO. 2 is equal to k minus 1 by 2. That is, 4 is equal to k minus 1. Therefore, k is equal to 4 plus 1, which is equal to 5. Therefore, k is equal to 5. Try some more examples for practice.